Evaluate the limit as x approaches 0 of sine of x squared over x. Now, we're getting a little bit spicier here with our x squared inside of the sine, but this is okay. So I'm going to rewrite this sine of x squared all over x. Now, to make our appropriate u substitution, we're going to need the thing inside the sine to also appear in the denominator. We've got an x squared in the sine and just an x in the denominator. So what we're going to have to do is multiply the whole thing by x over x. That is the creative version of 1 that we're multiplying by. So then we can rearrange things. We have the limit as x approaches 0 of sine of x squared over x squared times, well, when we move this x into that denominator, we've just got x over 1, which is x. So this whole thing is times x. Now we have the limit of a product. We can rewrite this as the product of the limits, so long as those limits exist. So we have the limit as x approaches 0 of sine of x squared over x squared times the limit as x approaches 0 of x. Now for this first one, we can make a u substitution. We can say u equals x squared. If u equals x squared, then as x goes to 0, u is also going to go to 0, because 0 squared is 0. And so we're going to end up with the limit as u approaches 0 of sine of u over u. We know that limit is equal to 1. I'm not going to go through the trouble of writing all of that out. I'm just going to say this limit is equal to 1 when we make that substitution. And then times the limit of x as x approaches 0. We can use direct substitution here. When we plug in 0 for x, that gives us 0. And 1 times 0 is equal to 0. So this initial limit is, in fact, equal to 0. I know that all of the other examples we've seen so far have had limits that are not 0, but it is definitely possible to end up with 0 as a limit, as we've seen here.